Because we are diving into the world of AI, the real AI impact with a powerhouse team from Red Hat.
Fatih and Rimma Iontel will share practical field-tested AI use cases that deliver measurable results. No hype, just real ROI. So let's give a warm welcome to the Red Hat team.
Hi, everybody. So we are going to take turns. I'll start, and then Fatih is going to continue. But he is going to introduce himself first because he's older.
Oh, my goodness. Well, that's kind of... Anyway, I'm not going to take it to HR. So, hey, my name is Fatih, and I'm happy to be here. Thanks for the invite. I'm based in Dallas, Texas. I'm ex-Google, ex-Verizon. All my exes lives in Texas. And I have been working in the applied ML domain 20 years, obviously, in the service assurance, revenue assurance, data engineering, data mesh. On Google side, I did a lot of data engineering with the classic machine learning with BigQuery, and so on and so forth. At Red Hat, mainly around the telco domain, a little bit of finance, a little bit of healthcare. Today, I collected some notes during the all presentations. I would like to touch it if possible. Other than that, I have academic side as well. I've just completed the degree in the Stanford, going for the doctorate in Polytechnic, Purdue Polytechnic next year, and God help me to pay for it. Thank you.
All right, Rimma Iontel. I am also ex-Verizon and then Red Hat, so 25 years altogether. I'm hardcore telco. I've always done only telco. Even my degree is in telecommunication networks. I started with SS7, for those of you who know what that means. And at Red Hat, I've done a whole bunch of different things, including delivery with professional services, and now I'm an architect in our city office. Yeah, I got it. Clicker. Some of the stuff that I'm going to cover, you might have heard pieces of it already. So we're going to go over some of the same ground that previous speakers. With a slightly different slant, because Red Hat, if you don't know, is an open source company. Everything, absolutely everything we do originates in upstream communities. So all of our code is open source. All the projects that our products become start as open source. If we create something internally, first we upstream it, and then we make it into a product. So our value to our customers is that first, they're not locked into us, right? They can always go and pick the same thing from upstream. What we bring to the table is our expertise, our security, hardening, professional services, etc. So, but as a product itself, all of it is available. So AI, right? That's what we're here for. As some of the previous speaker mentioned, AI is not just Gen AI, right? The fact that Gen AI made AI sort of accessible to everybody doesn't mean that's when it came to be. Telcos have been using AI for years. We just never called it AI, right? It was policy-based, rules-based decision-making, etc. And it's been in the network for quite a while. And one of the things that telcos had to face is that for them, AI was very siloed, right? Even though they didn't call it AI. But it was siloed, it was specific to the domain, right? It was used for troubleshooting, or it was used for radio access network, or it was used in the core network, or it was used in the optical network. But all the data that was used to make decisions was confined to those domains. What we see now is gradual realization that you have to make one single unified data framework to be successful with AI in the modern times. So we've seen the progression from those analytics to all the way to agentic AI adoption within telco networks. The other realization, right? Everybody talks about large language models. Is that the best solution for telcos? Not necessarily. A lot of the telcos, they don't need those generic large language models that can answer any type of question. They need something that can answer very specific, domain-specific questions. And that's what a lot of our customers are finding out, is that as an enterprise, they need a model that fits their goals. So they can start with a base model, they can fine-tune it, they can customize it, they can optimize it, and then it's going to serve their purposes a lot better. And on top of that, we've seen an explosion of open source models. So they don't have to start with anything proprietary. They can start with open models that have been, since 2023, popping up all over the place. So you can pick the model that fits best what your goals are, and then you can refine that. So we've seen a lot of telco customers start with Llama model because it was one of the early ones on the scene. So when they started working, that's what they had to work with. But now they have other options as well. And then they can use those open source models. They can create smaller, they can fine tune it, and then they can optimize it. And they can end up with a small language model that would serve their purpose, that would know their specific domain, and not just telco domain, but a specific server provider domain. It can, the other thing that telcos do and need to do, they can't necessarily put stuff in Amazon or in Google Cloud, right? Because they're very protective of their data and of their customers' data. So they have open source model that they can fine tune on-prem, so they're not dealing with Amazon outages, for instance. They're also not, they can control their costs and they can control their data. They own the model, they own their data, and they own the end results.
So I'd like to add one thing in here. Everybody talks about it. The models get better as the parameter size increases from billions to trillions, and somehow all day we missed the point that where we are heading, which was the January 2025 DeepSeek moment. How many of you here, the real benefit that DeepSeek has introduced was based on mixture of experts architecture? How many of you know what mixture of experts is? That's good, at least there's some knowledge. So to summarize, in those billions of parameters models, there are multiple layers of neural networks. When you're training them, you're training every layer, every parameter with different approaches, but yet, per token, you're activating all layers and all neurons. That is not efficient in the sense of execution time footprint. So what DeepSeek did, implement the mixture of expert that has sliced the models into expert networks, that is lowering runtime neuron activations, that is lowering your GPU consumption. So that was very important point that the DeepSeek team did. The second one, again, this year happened again, and if I go back, mixture of experts has been adopted by other frontier labs, including Google, OpenAI, and others. The last one, which was like a month ago, which is sparse activation. Sparse activation, the difference between sparse activation and mixture of expert is you don't necessarily pick based on the expert networks only, you also pick based on the neurons inside the expert networks. So we are more optimizing runtime resource usages. So why I'm telling you this? Because all comes with architectural changes in those models. not every model's architecture is equal to other models' architecture. Say GPT-OSS has a GPT-OSS architecture. Say Kimi K2 has a mixture of the sparse activation together with the MOE. So where this runtimes become super important if you're able to keep up with these new architectures, not necessarily models only, but also architectures. So this is where the open source community collaborating across frontier labs, across customers to catch up with these architectures that is promising not only quantization, optimization, but also those different layers of using the models for better price performance. Thank you.
So models are great, fun to build, architect, all of that. But where you actually get value in AI is inference, right? Serving your models. That's when your customers interact with your models. And inference is something that needs to be nowadays needs to be distributed. It needs to be very quick because studies show that high latencies basically discourage usage, which is usually not the goal. So what you want is you want to take your model, whatever it is you decided, you want to optimize it and you want to serve it with as little latency as possible in a most cost optimal way as well. So if you're a service provider, you don't want to lock yourself in anybody's hardware layer, in anybody's hyperscaler cloud. You want to have a flexibility to choose your own accelerators. You want to choose where you put your inference, and you want to know how much it's going to cost you to provide that inference. So something called VLLM, I don't know if you've heard of it. It's an upstream project it's a runtime environment for inference that allows you to gain all those benefits. So you get fast response time, you get very efficient memory management. You also have reduced cost because you can serve your models in a more optimal way, right? You require fewer GPUs, or in some cases you don't require GPU at all. And you can put in your own security as part of it, and you decide at what scale you can deploy it in, right? Depending on your needs. So something like this, right? Depending on the specific services you want to provide, you create specific pods with accelerators. Service providers often have different types of markets. In some markets, they want to put more expensive accelerators. Some markets, they want to put less expensive accelerators. Or they can give their enterprise customers a choice, right? You pay less, you pay more, depending on what you're using as your hardware layer. Same, and then you pick your model, you can have multiple models. You don't have to narrow it down to one based on the specific service you want to provide and specific task you want to be able to accomplish. You decide which model you use. So altogether, you create a stack, and then another upstream project called LLMD that was just recently created. It was founded by some very respected companies, including Google. We are actively participating in it, along with a whole bunch of other companies. And that allows you to do distributed inference. So it allows you to do things like separate your prefill from your decoder, for instance, right, in different hardware. It allows you to route intelligently, semantically, if you implement semantic routing as part of it, your requests. It allows you to manage your KV cache more efficiently. So all of those together add up to a much more efficient way of providing inference in saving money on GPUs, because you can decide where you place your GPUs. You don't have to have them everywhere in the network. And you can save it because you can put stuff at the edge of the network for telcos. You can provide very low latency as well.
So one of the things that is mentioned in the Google's presentation, there was a chart saying that, oh, the cost of token is going down. It's going to be easy to consume. It's not going to be expensive anymore. That's not necessarily true, because when you look at where we were and where we are today, is we are now talking about reasoning, chain of thought. That is increasing exponentially your token numbers. So although cost per token going down, but your number of tokens going exponentially up. So your total spending actually getting much, much more. So that's the trick point. If someone tells you, oh, use this model as a service or this, it's gonna be cheap, but you gotta question, okay, if there is, depends on obviously use case, and if you enable reasoning, that's not the true statement.
We lost our timer, so we're just gonna go until we're tired, basically.
Everybody died.
Yeah, until everybody is tired. Yeah, something like that. Well, we already talked about AI agents, right, before, several times. Telcos are talking about AI agents. It's something that makes a lot of sense in a lot of networking contexts. So what do you really need? First of all, just to reiterate, agents are software that uses tools and a little bit intelligent. So that's where your small language models can play a big role. And don't forget, AI agents don't have to be generative AI. They can be your machine learning models. So basic term for when you combine something that uses just regular machine learning models and something that uses generative AI models, if you want to learn a new mouthful, is there's actually a term for that. It's neurosymbolic. So you're combining the two types of models together to achieve a result. And AI agent is one of the way of doing it. You have tools. You want them to be reasoning, you want them to be collaborative, you want them to communicate with each other. And that's the basic advantage of using AI agents, because you can give them a goal and together they can figure out, they can create a plan of how to achieve that goal. One of the agents would be responsible for creating a plan, and then other agents would go and execute it, and then you would have an overseer to make sure that what they executed what is actually planned. And didn't break anything in the process as well. So that's important. There are lots of different things. It's a very quickly developing area right now, right? So everybody probably heard about MCP. MCP servers, it's for agents to communicate with each other to pass context between themselves. There are also several protocols that allow them to directly communicate, like ACP is one example. And then you want your agents to live on a platform, of course. We mention it because we are a platform company, so we find platforms super interesting and important. So you want certain capabilities on the platform that your agents or any other AI type of services are going to be running on, right? You want security, you want control your latency. Once again, you want to control your costs, and you want to have an environment that allows you to lifecycle manage your agents or any type of other AI applications. People oftentimes, and we've discovered it unfortunately time and time again, people forget that stuff needs to get upgraded. Stuff breaks and needs to be fixed. The whole life cycle management of deploying something, upgrading something, updating something, and then retiring something needs to be taken into account. Otherwise, you're going to end up with something that you deployed and was serving your purpose at one point, and then it's not useful anymore because you haven't been able to keep up with new feature development, for instance. It's just one example. It's something that we integrate into our platform called Llama Stack. It's an open source framework for developing agents. And it provides you different types of tools, right? It can give you tools for developing your own MCP servers. It gives you lifecycle management tools for your agencies, for your agents. It gives you security tools like guardrails, compliance tools. It gives you observability, right? Previous speaker emphasized why it was important. So the stack gives you that. And it can run on any hardware and use any accelerators, especially if you run it on top of our platform. So what are different components of the platform that you want to put your AI on? Maybe you want to develop models. Not everybody does. A lot of the service providers don't, but some do. Some from scratch. Some, like I said, they use open source models to start with and then fine tune. You want to be able to plug in any type of model you want, right? And you want to be able to tune it. You want to be able to serve it, right? Inference. You want to place it wherever it suits your needs, wherever you can, where you're serving your customers, right? Or whoever the customer is, external enterprise or your own internal teams. You want to place that capability as close to them as possible, whether it's on-prem or in a hyperscaler. You need to monitor, you need to optimize, etc. So all of those capabilities come from the underlying platform that's going to be hosting your IP application. I'm just gonna a little bit of a pitch for Redhat. Like I said, everything we do starts with open source. So on the left, what you're seeing are all. It's not comprehensive, but some of the top open source projects that were used to create our products. So you can see how they align and feed into our products. You can play with them for free as part of Open Data Hub, or you can try and integrate all these products together and see how much fun that is, and then give us a call. And in the end, this is pretty much what you would potentially end up with. Your choice of hardware with your choice of hardware accelerators, with your choice of models. As part of Red Hat, as part of IBM, we have our own open source Granite models, but you can bring your own. You can run VLLM for optimized inference. We have Instruct Lab integrated as well, either on OpenShift platform, which is our Kubernetes distribution, or as part of RHEL, which is the operating system. So you can actually play around with Gen AI, teaching it skills, etc. And then all sorts of different tools that allow you to do AI ops, develop your own models, create your own application. We have a whole developer suite as well. So at the end, you have your own future of your AI applications and your AI-based services in your hands. And now I'm going to hand it off to Fatih.
One thing to add in here, that's good, is we are not jailed to Granite. Personally, I don't use Gemini, not Gemini, the Granite. Obviously, I don't have $1 million to spend on Google Cloud. That's a separate topic. Our team, inference team, that gets the off-the-shelf available models on Hugging Face, including Kimi K2, QM3, whatever you name it, GPT 20 billion. They optimize and make it available on the Red Hat account in two variations. One is the certified version. The other one is the verified version. Certified version, we support the performance of those third-party models, even they are third-party, to run on VLLM. The verified ones, we verify they can come up and deployed and get into a point that they can serve you through an OpenAI compatible API endpoint. So long story short, you're not jail, you're not only destined to Granite. Any open weight model that is available on Hugging Face, our teams are monitoring in minute base to optimize them say quantization down to 4-bit, even 2 bits, and 1 bit coming with the quantum computing, but we're not there yet. And to all make it available for you to use. Why this is important? Because compression slash quantization lowers the size of the model. Depend on, say, if it is 32-bit, you're going down to 8-bit, you're compressing the model by 4 into a smaller size. That means 4 times less GPU to be used, okay? All right, so what is telco AI? So one of the key points that has been repeated in previous great conversations is, if you remember, again, Google's chart, there was this kind of a quadrant, and there was the far right, it was saying, hey, do experimentation. This is what it is exactly. Do experimentation with AI in your domain, with your use cases, and say, you know what, Fatih, I looked at this, the predictive maintenance case, I looked at this revenue assurance case, I looked at this anomaly detection, and I don't know which model to pick. Then what we do benchmarking per use case in telco domain for you already. We have benchmarks. We are collaborating with LM Arena, and we're going to have a collaboration portal that's showing the telco use case specific benchmark models. That is part of our repo as well. If you go under the telco SME folder, we have benchmark tests. One of the tests is the telco's last exam. So if you know, one of the most popular exam of the AI models is not necessarily Turing, but the humanity's last exam. We kind of created the version of it for telco's last exam. Okay, so the summary. AI needs to run wherever the network runs. So there's this conversation that is going, AI for run or run for AI or both. Is it chicken and egg? So we have an article coming on it soon, hopefully. And that is both. So one is AI can be used for network to make things better by means of optimization, lowering the MTTR, so on and so forth. Also, you can use network for AI. You can deploy smaller language models at the edge based on low latency requirements, based on use cases, based on footprints. So those queries doesn't need to go to cloud for expensive token consumption. So the use case dictates you wherever you have an expansion of your network, you should be able to integrate and leverage AI. There's no doubt on it. Obviously, having open source, secure, trustable, easy to replace models. So you heard the previous speaker that this is a fast-paced train. Models come so fast, and we see that, oh, this GPT, OSS 120 billion seems great, but the architecture I have with this cloud provider, Bedrock or whatever, is not necessarily supporting in this region. Why are you sacrificing? Follow the open source path with the VLLM. We do go hand in hand with these model architectures. All right, the telco grade. So if you notice my previous question, the previous speaker, you're using single cloud and you've kind of had a ginormous disaster and you're in the finance industry, how is it possible that your customers are not complaining? So this is where we recommend at least consider hybrid cloud. A little bit of on-prem, not necessarily full-fledged, combined with the cloud. Or multi-cloud. Say use Google Cloud. Here's a sponsorship for you. Together with AWS, have a kind of a distributed traffic for your models, but maintain your model selection for reliable and consistent responses for your use case. That's the key thing. All right. So Rimma already addressed the hardware-software partnerships across different layers, different partners, and we saw you guys are collaborating with NVIDIA as well. We are helping NVIDIA as well for their driver signing, make the CUDA work with the VLLM. We have very close tight engineering collaboration. So one key thing, as everybody's saying, in Europe there are regulations. Okay, so as a Turkish person who is born with the tendency to break laws, and going to US, it's not much different in business matter. You just break the law in US and then you apologize. If you look at how they have been training those models, all this data, and that they don't necessarily have the IPR. But life in US is different than life in EU, okay? So because you have heavily, closely monitored and you will pay penalties. In this case, if a company that is so obsessed with their own data value, their own oil, and they don't want to share it with the cloud. Because when you push the data over an API to OpenAI or others, you're handing over the ownership of that data, okay? You may say, you know what, it's just a simple query. Okay, so how many of you noticed in the last few weeks, when you go ChatGPT or Anthropic Cloud, even though you open a new, they remember you. Even if it's a new session, they remember your previous queries. They are keeping a record of what you have asked, what you have told before. So it's not that they are deleting data after you delete your session. It's not like that. They are keeping the data because they are leveraging to train it and offer you customized services. Okay. So last story, last point is avoid AI silos. Don't lock yourself into a particular platform. If you go with open source, VLLM offered by Google Cloud, now AWS coming, NVIDIA heavily contributing VLLM together with us. And if you go to the Hugging Face again, the platform, one of the key platforms that has been getting a lot of traction for models is the VLLM runtime. On the left bar top, you're going to see VLLM version, which models are VLLM compliant. All right, I'm not going to go through this. Everybody talked about it. Rimma also talked about it. The thing in here, I think, in our experience, as the title says, skip the BS and be realistic, be honest. So to be honest with you, we have been walking this path with the tier ones in US as well as EU, is they tried. They tried training their own models. And as this train goes fast, new architectures comes, and new data sets comes, it's not maintainable business from CapEx perspective. So, okay. So what I'm telling you here is custom model that is requiring gigantic data, gigantic GPU spending. We started, now not there anymore. We are coming into here and moving into here a little bit. Okay, so sweet spot. Everybody might say sweet spot is fine-tuning with your own data, but yet fine-tuning could be a really expensive thing too. Okay, what am I talking about? The recommendation, as people previously recommended, there's a book I will recommend you take a look at it. If you can afford, you should buy it, called AI Engineering by Chip Huyen. One of the great books in the Amazon. And she will walk through you the benefits and examples, who had done what, and then she will be pointing at, hey, instead of going top down, you should go bottom up. Start off-the-shelf model with your prompt engineering and context engineering. Also leverage retrieval augmented generation for your own local databases, and try to avoid more spending, but focus on the use cases and value generation. Okay, one use case we had done recently is customer intent classification. So customer calls the customer support center, the voice recorded, and the automatic Gen AI embedded system try to understand what this complaint is about. Is this about the billing? Is this about the coverage? Is this about the mobile phone? So intent classification used to be rule-based NLP systems in the past, but as coverage expands, the customer profile expands, dialect changes, multiple languages added. So you cannot maintain an NLP system with multiple languages and dialects. This is where Gen AI comes really handy to have a better structured output generation for intents. So in that case, we did use the fine-tuning with the VLLM running, and we kind of saw that the benefit of using fine-tuning added a benefit of 1.2% better accuracy. So we were around 86% accurate. Now we are 87.2 accurate. Does it worth it? Well, in some cases it does for emergency cases, this and that. That may work. Then we tried, okay, you know what? We should try the better context engineering, better prompt engineering. Let's think about it. So this is where everybody is talking that developers, junior developers have no jobs. Seniors are gonna be forced to retire. No, it's the middle ground. The middle ground is mind shift, which is previously it was feature-based development that usually start with the PLMs, designing, saying that, hey, customer wants this, try to observe what really customer wants and turning into a high-level design document, and then pass into engineering for those features. But usually those important steps such as HLD, LLD, most of the time skipped, and that was the critical part. So this change, emphasizing the importance of spec-based development, spec-based prompt injection. Okay, I use two things in here. Injection. Injection could be for good or bad. So here you are. As our opening speech, our beloved leader mentioned that his wife managed to convince the AI model to create an image. It happened. It happens. Why did it happen? Because, my beloved friends, this is not a complicated machine. You give it context, and if you grow the context over time, those system prompts that were part of the initial prompt being pushed to the bottom of the context, and context, as people talking attention heads now see, oh, there are higher attention layers in here that I can skip those system prompt guidelines. So that's the thing. So this is where we see context management, context lifecycle management, context compression is becoming important together with the addressing spec development. So why am I merging these two? Because specs could be really large files by means of customer requirements, 3GPP specifications, and there are multiple of them, thousands of them, and many pages, thousands of parameters to deal with, where you are increasing your context size, okay? So this is where new developments coming in the sense of model compression, while not using the important attention points. The other one is the coming thing, infinite context. So what we're gonna see next year, better context compression, and we're gonna see, oh, people start calling infinite context with these new model architectures. All right, so people already talked about how we should do the MLOps. You can use Kaiser, you can use Argo, whatever you like to use, but have it in control and have these surrounding features and facilities to be in place for data verification, resource management, process management, feature engineering. As you see, the AI ML code, the model itself is really the small balance stone in this wall. What matters is what you're asking the model by means of data with the RAG and the prompt itself. What matters how much you're spending where, and what matters how accurate this model for your use case, and is it really compliant with your expectations? And all this is ecosystem of open source projects. This is where Rimma was pointing. All right, so Telco AX use cases. Okay, I have 30 seconds. So these use cases that I'm gonna go fast forward, yeah. These use cases, we have around 13 use cases now, all tie into revenue assurance, fraud management, down to autonomous 5G network operations, agentic approach, one-stop know-how shop with the prompt engineering and embedding search. All Jupyter notebooks, Python cores, data sets are available. Data sets are being linked to Hugging Face, all open source. You can go look and experience yourself using your Python environment, Jupyter notebooks. I'm sorry, I'm a little bit underwater right now. And what we see, we have a really good trend and contribution from beloved Google, AWS as well contributing, NVIDIA contributing, AT&T, Verizon had donated some data sets together with the IoT part of the Google house for the Nest thermostat. So all this provides you a very fast forward jump with using reasonable models. Some of them are machine learning models such as logistic regression, linear regression, decision trees for anomaly detection, issue classification. Some of them are both Gen AI plus. Gen AI plus, I will go to very fast forward. Okay, so you had to, obviously you have to detect first the anomaly, okay? Root cause based on this time series data, which is classic machine learning, logistic regression, you can do decision trees. And based on your identified the issue, you pass that issue together with the log file, associated log file, to a proper Gen AI, benchmark Gen AI model to get an offer for issue remediation proposal. Okay, so I mentioned a couple of key things in here. One is kind of anomaly detection with machine learning. The second is attaching the necessary logs as a retrieval augmented generation. How do you do that? For that, you gotta go find appropriate log from your zip files, your folders. This is where VectorDB comes into handy. So we go map the anomaly detected keywords together with a timestamp into VectorDB cosine similarity. It finds the logs and passes to the LLM to generate you a proper issue remediation path. All right, I promise I'll be fast. All right. So long story short is where we are, we passed the stage of build your own models, but use off the shelf together with the good benchmark models for domain, for use case. If it is not good, accurate enough, try to use prompt engineering first, context engineering. If it is not good enough, do the supervised fine tuning with the tools in the open source domain available to fine tune those models with your own data sets. That will bring you price performance to get a high accuracy, both running on premise as well as on any cloud you desire through VLM runtime, which is open source. And I would like to thank you for your patience and thank you for inviting us. Thank you.
Just 1 second. Is this thing still working? He forgot to tell you the most important thing. What he was showing you, it's available open source in GitHub, and he didn't put the link to it.
Man.
So yeah, we want people to go and play with it. You can actually run it on your own laptops, download it. The whole package is available on GitHub. So like all the pieces are there. You can play with it and then contribute back.
If you search with the telco AX keyword on the GitHub, you'll easily find it. Well, that's a jet lag, okay?
Thank you very much. We will keep just for one question, I believe we can allow. And if you need water, I will put it here, so you can take it.
Any questions?
Who has the most important one?
CPM, which is the other part of the Chinese, for Tsinghua and Model Best people. They are probably your competitors in the international space in some way. So what is your opinion about their statement that they found the Moore's law for LLMs and SLMs, in which they stated, this is a December 2024 paper from them, that the density, the capability density, so-called, of the models are doubling every 3 months. And that is the direction, because actually the Communist Party took a 2020 initiative that they are going open source. So it's
Okay,
kind
so
of. What is your position and relationship? Yeah.
My position is be cool. So Redhat position is if the model is open weight and available on Hugging Face, we look at it, we look at the benchmarking based on use cases, and we obviously test it on VLM, on Redhat OpenShift AI, then we make it available. Open weight is the keyword. The other part is the dense models versus sparse models. Okay, dense models, like as I was hinting, activating all the neurons up there. Okay, that was the trend. No more, no mas, because now we have mixture of expert with the expert networking, and now we have sparse activation that is lowering your footprint. Funny enough, both of which, mixture of experts and the sparse activation, came from that frontier lab in China, which is the DeepSeek. One of the best models right now as for telcos that we have benchmarked so far is Qwen 3, which is again Alibaba originated. But again, the keyword is open weights.
And Moore's law is a self-fulfilling prophecy. So if you aim to, whatever, double, triple, quadruple, and you put resources into it, yes, you will, until you run out of resources. Yeah, I mean, but it's not a real law, right? It's just saying we'll do it. That's what they're seeing right now because of the amount of effort people are putting into developing. Yeah.
Maybe the last thing is, as you see, the main motto was run AI where it is needed. If it is at the edge, far edge, regional, central, how are you going to do this with the billion parameter models at the edge? You can't do that. If you cannot do that, it means, shall I sacrifice from using AI for my business? No. We have small language models that you can complement with the RAG, with the prompt engineering, that is still good enough for those low latency use cases.
Okay, thank you very much.
Thank you very much, Fatih and Rimma.